All right. In chapter 11, we are going to discuss three-dimensional space. Okay.
Is it coming out at us or going back?
Both. Okay. So when I say space, okay, like we are in space right now. We're three-dimensional objects, right? We are in three space. Okay. So before, up until now, we have worked in the XY plane, right? Like a piece of paper is a plane. Now we're in three-dimensional space. So we have X, Y, and Z as our three dimensions. Okay. So here is a picture from your book. Okay, this is what it looks like. I'm going to draw another picture of my own to kind of explain what is happening. All right. So we have an x-axis, a y-axis, and a z-axis. Okay. The x-axis is the one that's coming out at us. The y-axis is here. And the z-axis is the one that is going up and down. Okay? Now, why did I draw these lines half solid, half dotted? Okay? Where I drew the solid part of the axes, that's the positive side. The dotted side would be the negative side of the axis. Okay? So, here's our origin at 000. Right? 0, 0, 0. Okay. When we move up, this is positive z. Down is negative z. When we come forward, that is positive x. Going backward would be negative x. Going what looks to us to the right, that's positive y. To the left, negative y. Okay. So we have space. You see, space is made up of three planes, okay? So with the x and y axis, we have our xy plane, okay? That's what we're used to just working with, okay? So the xy plane is the one that looks like it could be like the floor. Okay? We have the xz plane. The xz plane is shooting through forward and backward. And then our YZ plane would be like a sheet of paper going through this way. Okay. In the XY plane, we have 4 quadrants. Okay. How many different pieces would this be broken up to with our 3 axes? 8. And we're going to call them octants. Okay, so we have 8 octants. Okay, now I understand that 3-dimensional figures are hard to visualize on a 2D surface, right? It is hard to draw 3-dimensional objects. Okay, so I'm going to try to explain the octants using Pod 2 here. Okay, so and this water bottle here is the z-axis. I wish I had something to color that. Okay. So these desks we're going to visualize as our XY plane. Okay. And then our YZ plane going to be between Emma and Jonathan's desk. Okay. So above Jonathan's desk, that would be octant 1. That is where they are all positive. Okay? Octant 2 would be here where Emma is, where the z's become negative. So octant 1, 2, 3, 4. We're going to go in the same pattern we would with just the 4. There are 8. So we're above the desks now. right? 4, 5, 6, 7, 8, we're going to go below where z is negative. 5, 6, 7, 8. Okay? Everyone turn in your book to chapter 11. What page is it?
812.
812.
Oh, I get it.
Okay? And on 812, they have the octants highlighted for you. Okay? So we're above where z is positive for 1, 2, 3, and 4. We're below where z is negative for 5, 6, 7, 8. Okay. 1 and 5 are stacked on top of each other. 2 and 6 are stacked on top of each other. Okay? Does that help? Yep. Okay. Like I said, it's hard to draw three-dimensional figures, okay? But the good news is, thank you to our engineering class, we have three-dimensional graph paper.
Oh, I thought you were going to say you don't have to draw that.
Nope. So, I have three-dimensional graph paper for you, okay? Yay. What you will need to do is you'll need to draw your axes. So here, I'm going to pick this for my z-axis. Here is our, which axis is this? X. And then our y-axis. What? Okay. So 3, 0, 0. Where do I actually get to move 3? Along the x-axis. So 1. See, they even have like these little grid marks for you. 3. There is 3, 0, 0. Okay. Now, is 3, 0, 0, is it lying in an octant? It is not lying in an octant. Okay, because it's on an axis. So, what plane would this be lying in? We could say that it's lying in the xy plane. We could also say it's lying in the xz plane. Great. Let's talk about 4, 0, 4. So, describe the movement. We would need to move this 4 along the x-axis. So 1, 2, 3, 4. We are not going to move anything for the y. And then we're going to move up z. Anytime you move up, I would suggest kind of making a little dotted line as you count. Okay, that way I know that you moved up from that spot. Oh, thank you. It had to be 4. 1, 2. Okay. Why is that dotted line important for us?
So you know it's on the z-axis and the y.
Okay, this is sitting up above the x-axis. If I didn't have that dotted line, it might look like it was sitting on the y-axis. You see what I'm saying there? Okay, so anytime we plot these points, we're going to plot their movement so we can actually visualize it sitting in an octant or on a plane. Okay. So where is this point lying? Is it in an octant? No. It is on the XZ plane. Wonderful. Okay. Now, these points were nice because we had at least one of the coordinates with a 0. Okay. 2, -3, 5. What I want you to do when you plot these points is make a rectangle with your XY coordinate and then move it up or down for the Z. So X is 2 would be here. Y is -3 would be here. So I would like you to make a little rectangle there. And so now our point is sitting here in the XY plane. And so then we're going to move it up 5 from that point. 1, 2, 3, 4, 5. There's point Z. Okay, so make a dotted rectangle with your XY coordinate and then move it up or down your Z. And make sure you kind of leave a trail, leave those little breadcrumbs so you can visualize where it is. Okay, what is this in an octant? It is. What octant does it lie in? Octant 4. How about this one? -2, 6, 2. Okay, I'll use green for that one. We'll call this point D. So -2, 6 would be our X and Y. So X as -2 and Y as +6. Okay, there's our rectangle, and from that point we're going to move it up 2. What quadrant, excuse me, what octant is this line in? Octant 2. Awesome. Okay. How do you find distance between 2 points in our XY plane? Yes. What is the distance formula?
It's a radical x1 minus x2 plus 1.
With some squares in there. So the square root of x minus x squared plus y minus y squared. What do you think it is going to be if we're in 3 space? The same thing, but with your z's thrown in there. Jonathan, do you have a baseball? Okay. Well, he had this yesterday. He had this yesterday, so I knew it was today. Okay. We have 2 points that are sitting in space. Okay. So here, Emma, stand up, hold this one. Jonathan. Oh my Okay, so hold them at two different heights. Okay, so we want to figure out the distance between these two, right? Well, they're at different heights, right? And right now, we've only worked with distance in just an XY plane, right? So if we if we measure from here to here, right below, if we don't change heights, I go to a point right below Jonathan's point, okay? We're just in the XY plane. See that? Okay? And how do we find distance in an XY plane? Square root of x minus x squared plus y minus y squared. Okay? So what we're going to do here is we're going to make a right triangle with these 2 points, where from here to here, we have our xy distance, right? And from here to here, we have the distance, our difference in our heights, okay? So here's Emma, here's Jonathan, okay? From here to here, you told me that this distance is x minus x squared plus y minus y squared. How do I describe the difference in their heights? Okay, whatever your z coordinate is minus whatever your z coordinate is, right? Okay. So if I want this hypotenuse here, that distance, okay, we can talk about the Pythagorean theorem, right? This distance squared equals leg squared plus leg squared. To solve for just d, we would square root both sides, and there's our distance formula in free space. Okay? We knew what it was going to be based on intuition, right? But this is the reason why this formula works. Alright, so let's do an example. Okay, this is not something that I expect you to regurgitate, but this is something that I wanted to show you why it works. Okay? I didn't want you to just take it and go with it. Let's understand why. Okay? So here we have 2 points. Let's find the distance between them. So we have the square root of 4 minus 2 squared plus 1 minus 1 squared plus 9 minus 6 squared. 4 minus 2 squared is 1 minus 1 squared. 9 minus 6 squared. So our distance is the square root of 13. What? Where are both coordinates? Octant number 1. Their x, y, z are all positive, so that would be an octant 1. Okay. If you would like three-dimensional graph paper, I don't know why you wouldn't. Here it is. Here's your homework. I realize we have about 8-9 minutes left, but you might be able to get almost all of this done in 8-9 minutes.